What's good, guys? Today we're going to be going over the antiderivative of second to the eighth x times tangent x dx. Um, Obviously, you know the derivative of, or if you maybe you don't know because it's kind of an obscure derivative. They don't really see too much these derivatives of these well, not inverse, but whatever the like complement signs or whatever you call them, of like basically cosecant, secant, etc., and cotangent. And but yeah, you should remember that the derivative of secant x is just secant x times tangent x. There's a whole proof as to why you could write it out and start taking derivatives, but that's for the basis of this video. For the basis of doing integral calculus, we're just going to say that we know this already and not really verify that that's true. So generally when you see something like this, especially when you have the integral, like one function and then its derivative in the equation, it might look a little weird because it's not two separate things really, but that essentially is what is here. So we're just going to use u sub because of that. Also because we have something to like a really high exponent, um, using u sub is also really nice. Alright, so we're going to set u is equal to secant x, and du is equal to secant x tangent x. I'm going to do the work in a different color. So what you should know is that you need to keep a secant x outside of your u, just so you can form this, so you can form a du. Okay. So what we're gonna do is we're just going to make it so that it's u to the seventh times du. This should be fairly obvious because what you want to do is you want to be able to form secant x, tangent x. You want to be able to form this so you can even form a du, so this can be a finished integral. So what you want to do, what you're going to want to do is save one of these secant x's. So just take it out, make it secant x to the 7th times secant x tangent x. You know, essentially just rewrite it as secant x 7th times secant x times tan x. And you should be able to see this is a derivative, this is a du, and that this is a u to the 7th, essentially. So that's what I did here. So then you just solve it, you just use basic integral stuff over u to the 8, and then 1/8, and then you plug your u back in, secant x 8, so plus c. So this is your finished integral for that. Now, there's a reason I chose this exact problem. Let me rewrite it further down here. Different color. Secant 8x tan x dx. Now, an interesting thing is about this problem, okay? It does not matter what number you have, like, say, make secant x to the y. I put a y here. It does not matter what you do for u. You could have 4, 5, 6, 7 for u. So let's say we have, I don't know, let's say we have 2 for u. So we have it, so u, or you have a degree of 2 on your second there. And then du is equal to, let's see, you take the u out in front, 2 secant x tan x. Okay? So now you should be able to see this is going to be squared up here. So now you should be able to say, okay, well, let's plug back in. Let's basically just solve this. Let me use a different color. So secant x, I need to have another secant squared out here. So I'm gonna have to leave 2 of that. Oh well, first there's no way I can get 2 here, so I'm just gonna put out 1/2 in front. We're allowed to do that. When you have a number times something, you can just divide over by 1/2 and then put that outside your integral. Um, so secant, it's in terms of u now. U, let's see, I'm gonna need a square, so let's do that with 6. So I'm gonna need 6 left, so this would be to the third. Because you see how I'm gonna need 2, and since I'm gonna need to leave 2 left. I'm gonna need secant squared left over from secant to the 8th. And if u is defined as secant squared, how many times can I get it so that if I multiply it by a number, there's only 2 left? And 2 times 3 is 6. 8 minus 6 is 2. And we need secant squared. So hopefully I didn't make that not make sense for you. So I'm just going to write it in terms of x as well, even though this isn't normally how you would write it, just because it makes sense, just because I want to explain this. So that's essentially what we have left. It's u to the third because it's secant 6x is this, okay? And then, not minus, times secant squared tan x. That's essentially what I've just done, is I've just taken 2 away from it. Like up here where I just took 1 away from it because my secant x was only had a 1 up here. All I did was take 2 this time because my secant was squared. Okay? So, mark that out. Let's actually solve this thing now. U third times du. Okay, well this is pretty easy. Just do basic anti-differentiation. 1/2 times 1/4 u to the 4th. And then plug back in my u, which in this case was secant squared x. 1/8 times secant squared x to the 4th, aka secant to the 8th x over 8 plus c, which is the exact same thing that we got here. This is, obviously I just wrote it over 8 this time instead of writing 1/8 out in front like I did up here. So yeah, it's a really cool way of doing u sub, and it's a very good example of how sometimes you can take out different. There's not always one defined answer to what has to equal u, especially when you're dealing with exponents like this. Uh, this is a very sort of specific type of problem, so don't go looking for this sort of thing in every problem. It's very specific, and it's really cool. Thanks for watching. Leave a comment if this was interesting or, somehow helped you in some sort of way.